Welcome to Factoring Quadratics, Day 3. So far we've learned the decomposition method, the area model. We went through and factored, and then that was like day 1, getting set up with the product sum table and so forth. And then day 2, I showed you a few new methods like the Australian method and the guess and check method, but we kind of ramped it up, made the questions a little trickier. With letters all the way through and so forth, and lots of finding the GCF before you factor away and factor by grouping. All right, so we're going to spend one more day on factoring quadratics today, and I'm going to show you some, some trick methods and things that you can, if you can spot them, you can complete factoring a little quicker. So again, if you're having issues today and you're happy with being able to do decomposition method or area model, you could just kind of keep rolling with them. But it will be key to try to get faster at these. So that's why keep an open mind with these new methods. But I won't be assessing you that you have to be able to use this method here in order to get to the answer. So when I give you the checkpoint today, if you prefer to just kind of go back to one of the other methods that you've been using to get to the answers, then that's okay as well. So the way I'm going to introduce this is I'm going to get you to kind of investigate what these ones here, where it's x plus 3 squared or x minus 5 all squared and so forth. Okay, so we're going to get to these answers and then kind of analyze what's going on and make up a conclusion. Okay, so I went ahead and calculated the questions out here. Just a reminder, when it's x plus 3 squared, it's like you write a copy of it again, right? You write it twice, and then you go through and FOIL it or use the area model. Okay, so don't take the 2 and rainbow it in. You can't rainbow in exponents. You can rainbow in things when they're in front here, the actual coefficients and so forth, but don't rainbow in exponents, okay? So from there, you go through the 4 calculations. Like if you're doing FOIL, you're going to go, so you're going to go first, outer, inner, last. Okay, so you do the 4 calculations and then you get to x squared. You get to x squared plus 3x plus 3x plus 9, and then you clean up the middle term, add them up, and you get to there. So we have seen this method before when we went from here to there. We were looking at, what did we notice from getting from this question here to the answer? Well, we just took the first term and we squared it, and it became x squared. We took the last term and squared it, it became 9. And then the one in the middle, we just took the x and the 3, and so the x and the 3, we multiplied them, and then we multiplied the whole thing by 2, and we got the 6. Okay. All right, so same thing, analyze the next 2. X becomes x squared, the 5 becomes positive 25, and what did we do with the middle term? Well, we got negative 5x, but then we're going to take that and multiply it by 2, so then we get the negative 10x. All right, and from here, this 2x squared again becomes 4x squared. The 2x becomes 4x squared. The 3 becomes 9. All right, and then to find that middle one, you're just going to times 3, which is 6x. But then you're going to multiply both of them by 2, and you get the 12x in the middle. So that's something we did in our previous cycle. So whenever we saw binomials all squared like this, we can jump right to the product. Okay, so I saw some of you actually using this. I know most of you just prefer to just FOIL out stuff and so forth. Okay, so today what we're going to do is we're going to go backwards. We're going to go from the trinomial here back to the factored form. Okay, still using the same idea that we did when we went forward. So here are the general rules. So basically, if you have a perfect square trinomial, so it just means like you're going to have a perfect square here and a perfect square here. Okay, so if you're taking a look here, so again, if you're wondering what perfect squares are,
I have this note later on in the note where here are the perfect squares. So 1, 4, 9, 16, 25, 36, etc. These are all perfect squares because they came about by multiplying the same number together. Like 4 times 4 made 16, 8 times 8 made 64, right? 12 times 12 made 144. So these are all perfect squares. You need to have them memorized so you can do these quicker. So if you can recognize, oh, I have a perfect square, so then you can use some of the trick methods today. Okay, so if you have a perfect square trinomial, this is what it will look like. So you will have the first term is a perfect square, right? Like x squared is x times x made x squared. Okay, so even if we write that at the top here. So you know that x times x is x squared. So that's a perfect square as well because you took the two of the same numbers and you multiplied them together and made x squared. Okay, so now if you want to work your way backwards, if you have the perfect square trinomial here and you want to work back to the factored form, what you're going to look for is, do you have so for example, if you don't know if you have a perfect square trinomial, you're going to look and check, okay, so can I square root this one? Can I square root that one? Okay, so if I did that, I would get an x and I would get a 3. Okay, so you're like, oh, I can actually square root those. So maybe I have a perfect square trinomial. On top of it, if you have a perfect square trinomial, you will have, like both of the third terms will be a plus. Okay, the first term will be a positive as well. Okay, and the only difference is that you can have a minus or a plus in the middle. So in this case here, so far it's looking good. I do have a plus here. The first one's a positive. So I'm square rooting the first two and I get x and 3. So I'm checking to make sure that if I take these two and multiply by 2, do I get the middle one? Whoops, yes. Okay, so 3 times x times 2 will make 6. So I know I have a perfect square trinomial, so I can use this little rule here. So if I find my a and my b, so all I'm doing is I'm taking my first term and I'm square rooting it, and my second term and I'm square rooting it, I can write the factored form like that. So here, this is my a, and that's my b. Okay, so I can go right to the factored form. I can go right to the factored form here and write, oh, x is my a, b is my 3 here, and then I'm writing a plus because if I had a positive in the middle, it becomes positive. Here, okay, so say we did the check for the perfect square trinomial, the middle one is a subtract. So we would write subtract, okay, and then the a and b would have been x and 25, or x and 5. Okay, and here it would be 2x and 3. Okay, so then you jump right to the factored form here. Okay, so anyway, it's a little tricky to show you this just kind of this way. So we're just going to do some examples right now. So, here's the first one, a, x squared plus 6x plus 9. So again, you are analyzing it to see if you have a perfect square trinomial. Okay, so you can kind of go along here and go, oh yeah, I can square root that. Yep, I can square root that. So if I square root them, I would get an x and I get a 3. Now, if I take those two and multiply them by 2, do I get 6x? Yes, you do. So your answer would be x plus 3 squared. Okay, because again, that middle term here is positive, so I write plus 3. Okay, let's try the next one. All right, so you come along and you're like, oh, I notice there's a perfect square here at the end, so let's analyze it. Okay, and yep, so if I square root that, I get a w, and I square root that, I get 6. So then I'm analyzing, if I take 6 times w times 2, will I get 12? Yes, so I have a perfect square trinomial. I can go w, and then I go subtract because the middle term is negative. 6, all squared. Okay, so yeah, and then just keep going along here. And so can I square root a squared? Yep, you get an a, square root 49, 7, okay. And then if I take 7a times 2, do I get 14? Yes. And because that middle one is negative, so write minus 7. Okay, and keep going if you want to work ahead. All right, so
So these first three here, were uh, simple trinomials. Okay, so now we're looking at the complex ones here. Okay, so we're analyzing it again. Do you see a perfect square? Okay, and you should also be still going through the steps of, oh, step one, do you see a GCF? Okay, all right, so here when I'm analyzing it, no, it's just a GCF of 1. Okay, step 2, then go and factor. Okay, factor with whatever methods that you've picked up, okay, that you're comfortable with. But again, if you're finding you're pretty confident with decomposition, start trying guess and checks. Try this new perfect square trinomial method on everything that you can, okay? So again, I'm just quickly going through and I'm square rooting here and I'm going, okay, the square root of 4 is 2, the square root of x squared is x, square root of 9 is 3, okay, so then do a quick check, 6 times 2, or 3 times 2 is 6, times 2 is 12, yep, this is a perfect square trinomial, okay, and there's your answer, all right, and then keep going. Let's see here, we haven't used green. Okay, all right, so 25x squared. So again, this is all the way over the x as well. So that's a 5x. Okay, square root of 16, 4. Okay, 5 times 4 is 20, times 2 makes 40, yes. Okay, so we have 5x subtract 4 all squared. Okay, so a lot less writing. I think that cut down a lot of time for factoring these trinomials. So that's why it comes down to, can you recognize what kind of question you have, and then can you use this tool or that tool. But again, if you're a little bit overwhelmed, remember the decomposition method would work great here, or the area model, okay? Okay, so people get pretty excited about this method because they're like, oh, it's so much faster. It's just really quick and easy to do. So they get really excited and then they want to use it everywhere. So remember how I was going through, I was getting you to square root the first one, square root the last one, and then still do the check. Like, okay, if I take 6w and then multiply by 2, am I getting that middle term? Okay, if you were like all these conditions have to apply, then yes, you can jump to this method. All right, I've collected some more here, where here's an example of, it looks kind of like what you have above here, like a perfect square trinomial, but if you don't check all the conditions, you will end up with the wrong answer. Okay, so right away, so you're going through and you're looking at the first and the last term, and oh, wow, yeah, those are perfect squares. Great. Okay, so you kind of do this little hook thing, and then so you're like, okay, that's x. If I square 36, that's 6. But if you look here, all of these ones above, the last term was positive. Okay, so if you look here, all of the ones were positive. So in this case here, it's negative. So you got to be careful and think you can't square root a negative. Okay, and then on top of it, if you were to check the other condition where if I take 6 times it by x and multiply by 2, I should get 12, not 5. So this is how you're like, okay, this method can't be used here. This trick method can't be used here because you don't have a perfect square trinomial. Okay, so this is not a perfect square trinomial. So again, if we look up here at the rules, you have the first term, which is a squared. You have the last term, which is b squared. But see how it's always plus b squared. It's always positive a squared, right? And then the thing that changed was the middle term could be positive or negative, but the first term and the last term had to be positive. So be careful with that as you start jumping in. You see, oh, I see a perfect square here. I can do this trick, but no, it doesn't work. So, since it's not a perfect square trinomial, you go back to what you were doing before, where you are analyzing. So then that means I have to do the product sum table. Okay, so the sum. Let's go pen. Okay, the sum of -5 and the product of -36. Okay, so from there, hopefully you realize that 4 and 9 will work here. Okay, so
out of 4 and 9, 9's bigger, so I'm going to make that negative, so I can add to make a positive 5 or negative 5. But when I multiply these, I get negative 36. So those are my, and then because I know it's a simple trinomial here, a equals 1, I know I can just jump right to the factored answers. Okay, all right, so move on to the next one, same thing. Kind of recognize, oh, I have some perfect squares. Oh, wait, I don't have a positive here at the end, so I can't use this new method. On top of it, if you had gone ahead to the next part where you square rooted them anyway, 4 times x times 2 does not make 6. Okay, so there should be a couple different things there to stop you from going with this new trick method that you learned. All right, so again, you're doing the product sum of this method. So let's do that here. So the sum of 6 and the product of negative 16. Okay, so 8 and 2 would work here. Okay, one of them, okay, so since the sum has to be positive, I'll make the bigger one positive, and the other one's negative. So negative 2 and 8 make negative 16, but when you add them, you get positive 6. So, and again, it's a simple trinomial, so I can jump right to the answer here. Okay, so I'm going to give you lots of practice questions today. You can think of it as the factoring Olympics, and I want you to go through and do tons of them. This is how you get really good, you get fast, you can experiment with all the different tools and methods that you've learned, and and then even use these new ones if you can recognize perfect square trinomials. Okay, so get really fast and good at these, and then there'll be a checkpoint. Okay, so that was one of the tricks I was going to show you today. There is another one. So again, I'm going to go through an investigation to kind of ease into it. If you're finding it's not useful, just jump right to the examples, okay? All right, so yeah, and the reason why I want you to sometimes explore your way to a rule is that it'll be easier to remember it if you can remember how you kind of got to the rule, okay? All right, so here, again, we're just expanding. So we have what's going on here is that you have the same, like the first term and the last term, but they're different. The binomials are different by the ones that subtract, ones that add. Okay, so go through and FOIL those out, and let's analyze what's going on. Okay, so I've gone ahead and FOILed those out, expanded them out, and this is what we got. So we noticed that, so they were similar. They were only, the binomials were different by an adding, subtracting. So what happened when we FOILed it? So we, did our 4 calculations or multiplications, and we found that the middle terms always ended up being the opposite signs. Okay, the exact same number, opposite signs. So what would happen is that they would cancel out, and then you would end up with just 2 terms in your final answer. Okay, and they all ended up negative. And then if we keep analyzing it and kind of using what we did before, we're looking at perfect squares. And we're noticing, oh, okay, yeah, they're both perfect squares. Okay, even this 4m squared is the perfect square. The 25 is perfect squared. Okay, so here is the other trick method today. It's whenever you see a difference of squares. Okay, so again, remember our goal, this is expand. Our goal is today to go that way. Okay, we're trying to factor. So if you see a difference of squares, so perfect squares, so like x squared is a perfect square, 1 is a perfect square, 9 is a perfect square. So if you see a difference where they're subtracted, you can use this method where you can go right back to this method, the factored form, and all you do is take your a and your b, square root them, right, the first and last, and square root them, and you get to your 2 factors. Okay, so if I just do 1 down here, you can look at that example. So if we're looking at x squared minus 9, so think of it as like what we're doing before. You're noticing they're perfect squares, so you can kind of put the hooks on them and go, okay, I'm going to square root both of those. And when I do that, this is an x, and that's a 3. So if and I know this is a difference of squares, so I can just write x, right? And then remember how 1 has to be a plus and 1 is a minus. Okay, 3s are not behaving today.
So that is the other trick method, just to be able to do these a lot more efficient. Okay, so here's the rule. Let's try some examples now. Okay, all right. Here's the first one. Okay, just did one like this. But if you're starting from scratch here, just so again, this is important. You can use this if there's a difference, okay? And then they have to be perfect squares. So if there's a difference here and perfect squares. Okay, so this one is going to be square rooted, and then you can kind of just write your notes here and go, yep, those work. So those are the two values that you need. And again, remember, it doesn't matter which way you write the factors, still the same. So I'm just going to write it the other way. So up here I put the plus first, the minus. Here I put the minus and then the plus. Okay, but that is quickly a quadratic function here, or relation here, factored really quickly to its factors. Okay, because we recognize that, oh, it's a difference of squares. All right, so try the next one. Again, so you're analyzing it, you're noticing perfect square, yep, perfect square, yes, awesome, and it's a difference. Okay, so these ones where there's two terms, you can use this method because in the previous lesson, if you were trying to remember what we did, I told you to approach this and say, oh, the middle term's missing. So when you did the product sum, you write sum of the middle one's missing, but the product is -4. Okay, and then from there we figured out, oh, whenever the sum was 0, we knew that all we had to do was square root this one, so we needed 2, and we always needed the opposite signs. Okay, so that's what we did before. So again, it takes a little bit more writing and work. So if you can recognize, oh, it's a difference of squares, oh, that means that I have to square root both of these, and those are the two values that I'm going to write, or terms that I'm going to write in my, so again, here I can mix it up, make that one plus this time, and I don't know why I'm writing a 4, it should be 2. There we go. Okay, so we can get to the factored form really quick, okay, because again, I know setting up a product sum table takes some time. All right, so if you're starting to see this, figure this out, go ahead and work ahead of me. And but yeah, always be paying attention. Do you have a difference of squares, perfect squares? Okay, so right away, get really excited because you're like, oh, these are easy, I like them now. All right, so M4, okay, we know we have a difference. Okay, so that means M minus 4 and M plus 4. Okay. We haven't used pink yet. Okay, so again, A square root, B11. And I'm just purposely alternating. You can write them all the same way, all the subtracts first, all the adds first, doesn't matter. All right, so you're getting pretty excited. These are all going really fabulous and really quick, and excited to learn this new method. But then, oh, I'm just going to shift my note here. But then you're noticing, oh, okay, so look at that. Just keep going. Oh, wait, this is not a subtract, okay? It has to be a difference. So if you ever see this, okay, and again, remember, always look for the greatest, remember, step 1, look for the greatest common factor. Okay, step 2, then you factor, okay? Go through those steps. Okay, so we're noticing here that we don't have a difference, so if you ever have an add, this isn't going to work. So you write cannot be factored. Okay, so if you don't have a difference, cannot be factored, okay? All right, keep going.
Okay, so you see a difference here, so you're going to check, oh, do I have perfect squares? Yes, I do. If I square root that one, I get 2x. This one, 3. Okay, and then just remember, this method is different from the other one that you just learned in the sense that they're both they look the same, but they're opposite signs. Up here, with the ones that you did here with the perfect square trinomials, remember, and it ended up being they were the exact same things that came out, right? Like here, x plus 3 came out. That. Okay, so when there's three terms like that, you know you have a perfect square and a perfect square, and you know the middle one will multiply up to 2 times those two numbers. Yeah, you can do this method, but you write the sign twice. Like it's the same sign twice, right? Both of them positive, both of them are negative. But here, one is positive, one's negative. So just make sure, and then don't take these and like suddenly square it like I don't know. Just want to clean it up and then square it. No, because they're not the same. Okay, one's positive, one's negative. So don't do that. Okay. All right. Keep going here. Again, check for the GCF. I should have been doing that all the way through, but I want you to make sure you're doing that. So, do I have a greatest common factor here? Okay. So you're looking at 16, 49. Any numbers work in there? Nope. How about the letters? Nope. Okay, so you know GCF's 1. So then go ahead and try the check method. You know that it's a subtract in the middle. So if I square root that, you get 4a, and you square root this one, you get 7b. So then you can okay, so it's getting more complicated. You got lots of letters, but now you can write one as a subtract and the other one as add. There you go. Okay, so good job. All right, next one. So again, always check the GCF. And so step 1, GCF. Is there one? Okay, so this is H that we're dealing with right now. Okay, so you're analyzing the numbers 3 and 27. Yes, there is a GCF. 3, any letters? No. So let's give you some more space here. So go through and do what you did before with common factoring. Okay, so you're going to take the 3 and divide it out. Okay, so again, forgetting this greatest common factor step has given a lot of students grief, so don't forget it. Okay, so divide the 3 out. That leaves me an x squared and a 9 left, okay? And at this point, two students will go, oh, I factored something, I'm done, okay? No, always analyze what's left in the bracket here and see if you can factor it further, okay? So because you want, whenever I say factor, I mean factor as far as possible, as complete as possible that you can, and then write the final answer. So here I am noticing, oh, it looks like my difference of squares. So you can do this little, okay, reminder to go, okay, I need to square root those. So when I do that, okay, so I'm going to write this, keep writing that 3 along, okay. So now you know, okay, so like if we're still writing the work, so you're like, okay, that one becomes an x, and that one becomes a 3, right? So let's write our final answer here. So you have the 3 that came out, and then you also write x minus 3, x plus 3 as your final answer. Okay, so when I go to mark that one there, I'm looking for greatest common factor and then the 2 factors. Okay, all right, so those are the 2 methods that I wanted to show you today. I'm just going to show you this little toolbox here of everything we've covered so far. Okay, so here are the perfect squares. So again, if you don't have those memorized, get them memorized, or have the sheet out in front of you. Because again, these methods work if you can recognize the perfect square. So like, hopefully, like all these ones we did here, 9, 4, 16, 121, you know, like 144, 25, 9, all, like 49, 64. Those are all perfect squares. Up here, same thing. That one at the end, right? These are all perfect squares. Letters, if they're squared, are perfect squares. But if you have a number and a letter like that, and you have the number is a perfect square and the letters squared, you have a perfect square. So be able to recognize those. So again, have this out in front of you, just kind of tape it to your wall so you can stare at it a lot if you don't have them memorized. And then as you're going through factoring, always step one, look for greatest common factor, okay? Step two, remember I showed you that simple trinomial method. So if you know a is equal to 1, right, you can use the product sum, and then you don't have to use decomposition. You can go right to the factors. So you can use that. If you don't have, but if you notice that you do have a perfect square trinomial, then use this new method that you were shown, okay? Or if you have a difference of squares, use this method. And if you don't have those, then you kick in decomposition, because decomposition takes time, okay? So using your product sum and then and so forth, area model, some people use that.